Hi guys, a very good day to everyone, and welcome back to Budget Power Electrical Solutions. In this episode, we'll continue learning important IEC electrical symbols. Understanding these symbols is essential for reading electrical schematics, control diagrams, and engineering drawings correctly. We'll look at what each symbol means, how it works, and where it is used in real electrical circuits. If you find these lessons useful and would like to continue learning with this channel, please subscribe. Give the video a thumbs up and share it with others who may find it helpful. Now, let's get started with symbol 19. Here is symbol 19. Do you know what this symbol represents in an electrical drawing? Take a moment and think about your answer. The answer is a circuit breaker. It carries current during normal operation and automatically opens the circuit during overload or short circuit conditions. It can also be operated manually for switching or isolation. In this motor feeder circuit, the three-phase supply passes through the circuit breaker, then the contactor and overload relay, before reaching the motor. The circuit breaker protects mainly against short circuit and high fault current, while the overload relay protects the motor from sustained overload. Look carefully at this symbol. It is used in control circuits, it works electromagnetically, and it operates a set of contacts. Can you identify it? The answer is a contactor coil. The coil terminals are normally marked A1 and A2. When control voltage is applied across these terminals, the coil creates a magnetic field and pulls in the contactor mechanism. As a result, the normally open contacts close and the normally closed contacts open. Now let's look at a typical DOL starter circuit. When the start push button is pressed, the KM1 coil energizes. Its auxiliary normally open contact closes to create the holding circuit, and at the same time, the KM1 main contacts close in the three-phase power circuit, supplying power to the motor. If the stop button is pressed or the overload relay trips, the KM1 coil de-energizes, the contacts return to their normal position, and the motor stops. So the key point is, the coil controls the contactor, and the contactor contacts control the load current. Do you know what this electrical symbol represents? Here are some clues. It detects current imbalance, provides earth leakage protection, and helps protect against electric shock. Can you guess the answer? The answer is an RCD or RCCB. It compares the current flowing through line and neutral. If some current leaks to earth, an imbalance occurs, and the device quickly trips to disconnect the circuit. During normal operation, line current and neutral current are equal. If a fault causes current to leak to earth, the RCD detects the imbalance and trips the supply. Remember, RCD protects against earth leakage, while the MCB protects against overload and short circuit. Do you know what this electrical symbol represents? Here are some clues. It protects against overload, trips during a short circuit, and is commonly used in distribution boards. The answer is an MCB, miniature circuit breaker. It automatically disconnects the circuit when the current becomes too high due to an overload or short circuit. After the fault is cleared, it can normally be reset. In this practical circuit, a 16-amp MCB protects the socket and connected load. During normal operation, current flows through the MCB to the load. If an overload or short circuit causes excessive current, the MCB trips and opens the live conductor, disconnecting the supply and protecting the wiring and equipment. Do you know what this electrical symbol represents? Here are some clues. It protects against overcurrent. It opens the circuit when current becomes too high, and it is widely used in control and power circuits. The answer is a fuse. A fuse is connected in series with the circuit. If excessive current flows, the fuse element heats up, melts, and opens the circuit to stop the current. In this control circuit, the fuse protects the transformer and wiring. During normal operation, current flows through the fuse to the transformer. If a fault or overload causes excessive current, the fuse element melts and opens the supply. The control circuit is disconnected, and the blown fuse must be replaced before the circuit can operate again. Do you know what this electrical symbol represents? Here are some clues. It changes voltage level, provides electrical isolation, and is commonly used in control circuits. The answer is a transformer. It transfers AC power from one circuit to another through magnetic induction. Depending on the winding ratio, it can step the voltage up or step it down. In this motor control panel, 230 volts AC is supplied to the transformer primary. The transformer steps it down to 24 volts AC for the control circuit. That lower voltage is then used for the stop and start push buttons, the KM1 contactor coil, and the pilot lamp. So practically, the transformer gives us a safer low-voltage control supply and also provides electrical isolation. Do you know what this electrical symbol represents? Here are some clues. It measures high currents safely, works with ammeters and protection relays, and is commonly used in power panels. The answer is a current transformer, or CT. It converts a high primary current into a much smaller secondary current, such as 5 amps, so meters and protection devices can measure it safely. In this power panel, the main load current passes through the CT primary. The CT produces a smaller proportional current on the secondary side and sends it to the ammeter or protection relay. This allows high current to be monitored without connecting the instruments directly to the power conductor. One important rule: never open the CT secondary while primary current is flowing. Do you know what this electrical symbol represents? Here are some clues. It measures high voltage safely, works with voltmeters and protection relays, and is commonly used in switchgear and substations. The answer is a voltage transformer, or potential transformer, VT or PT. It steps high AC voltage down to a lower standard voltage so meters and protection relays can monitor it safely. In this switchgear panel, the 11 kV supply is connected to the VT primary. The transformer steps the voltage down to about 110 volts on the secondary side. This lower voltage is then supplied to the voltmeter and protection relay, allowing the high voltage system to be measured and monitored safely. Do you know what this electrical symbol represents? Here are some clues. It uses a single winding with a tap. It can change the voltage level, and it is used in voltage control and motor starting applications. The answer is an autotransformer. It uses one shared winding, and the tap provides a different voltage level. It can step the voltage up or down, but unlike a two-winding transformer, it does not provide full electrical isolation. In this circuit, KM1 is the main contactor. KM2 connects the motor through the autotransformer for reduced voltage starting, and KM3 is the bypass or run contactor. At startup, KM1 and KM2 operate, so the motor receives reduced voltage through the autotransformer and the starting current is limited. After the preset time, KM2 drops out and KM3 closes, bypassing the autotransformer. The motor then runs directly from the three-phase supply at full voltage. Do you know what this electrical symbol represents? Here are some clues. It works with three-phase AC, changes voltage level, and is commonly used in industrial power distribution. The answer is a three-phase transformer. It transfers three-phase AC power from the primary to the secondary and can step the voltage up or down depending on the winding ratio. In this practical circuit, the 11 kV three-phase supply passes through fuses F1, F2, and F3 to the transformer primary. The transformer steps the voltage down to 400 volts three-phase on the secondary side. This 400-volt supply then feeds the distribution board, which supplies loads such as the three-phase motor and industrial control panel. Do you know what this electrical symbol represents? Here are some clues. The primary and secondary are electrically separated. It provides isolation, and it is often used for safer control circuits. The answer is an isolation transformer. It transfers AC power from the primary to the secondary by magnetic induction, while keeping the two circuits electrically separated. In this control circuit, the 230-volt AC supply feeds the primary of transformer T1 through fuse F1. The secondary provides an isolated 24-volt AC control supply for the stop button, start button, KM1 coil, and pilot lamp. Because there is no direct electrical connection between the primary and secondary, the control circuit is separated from the main supply, improving safety and reducing the risk from supply-side faults. Do you know what this electrical symbol represents? Here are some clues. The secondary winding has a center tap. It can provide two equal voltages, and it is commonly used in power supplies and control circuits. The answer is a center tap transformer. The secondary winding is divided at the center point, creating two equal voltage sections. The center tap can be used as a common or 0-volt reference. In this practical circuit, 230 volts AC is applied to transformer T1 through fuse F1. On the secondary side, S1 and S2 provide equal AC voltages with respect to the center tap, CT. Diodes D1 and D2 rectify alternate half cycles, producing a full-wave DC output, while the center tap acts as the common return for the DC load. Do you know what this electrical symbol represents? Here are some clues. It provides an adjustable output voltage, uses a movable tap, and is commonly used for testing and voltage control. The answer is a variable transformer, or Variac. By moving the tap along the winding, the output voltage can be increased or decreased smoothly. In this test circuit, the 230-volt AC supply passes through fuse F1 and feeds the Variac input. By turning the adjustment knob, the movable tap changes position on the winding and the output voltage can be varied from low voltage up toward the supply voltage. The voltmeter shows the selected value, and that controlled voltage is then applied to the test load, such as a lamp, motor, or other device under test. Do you know what this electrical symbol represents? Here are some clues. It is a three-phase transformer connection. It uses a delta primary and star secondary, and it is commonly used in power distribution systems. The answer is a delta star transformer. The primary windings are connected in delta, while the secondary windings are connected in star. This arrangement allows the transformer to change the voltage level and also provide a neutral point on the secondary side. In this practical application, the high-voltage three-phase supply feeds the delta-connected primary, and the transformer steps the voltage down to 400 volts on the star-connected secondary. The star point provides a neutral, allowing the distribution board to supply both three-phase loads, such as motors, and single-phase loads, such as control circuits and sockets. You have now learned a wide range of important IEC electrical symbols, along with their functions and practical applications. But this is only the beginning. There are many more symbols, circuits, and real-world electrical concepts still to explore. So keep learning, keep practicing, and keep strengthening your electrical knowledge. Subscribe to Budget Power Electrical Solution. Give this video a thumbs up and leave your questions, ideas, or comments below. Let's continue to empower your electrical knowledge, one practical lesson at a time. Thank you for watching Budget Power Electrical Solution. Stay connected, keep improving, and I'll see you in the next episode.